Hello guys, I welcome you all to this video. From here onwards, we are starting off with learning a new gateway in our LLM gateway journey. And the name of this new gateway is MeshAPI Gateway. Now MeshAPI is a new gateway in the market, and MeshAPI offers us integration with 1000 plus LLMs with one single line of code, which is what is the specialty of all the gateways available. Now, what makes MeshAPI Gateway different from all the other gateways is what we are going to talk about. MeshAPI offers us more than 30 plus features. And these are just not some random features which are, given in all the LLM gateways. These are some unique features: speech to text, video generation, image editing, structured outputs, moderations, which means guardrails kind of thing, audio translation, bring your own keys, which means you can connect your cloud as well with this particular gateway, web search, prompt template, response caching, automatic fallback. You know, all these are really amazing features. And with these kind of features, you don't even need a framework to build your agentic AI applications, is what I'm trying to take you over there. Okay, and this is how Mesh API is different from these all frameworks. Let me show you a very good product. Okay, what are we seeing over here? This is NeuroCart. All right, this is a product recommendation page where this page offers us different kind of products in the form of courses. All right, educational courses. Now let us say if I click onto this particular framework. Okay, we are learning agentic workflows with LangGraph, right? In this, what happened currently is the moment I clicked onto this particular page, my signal was logged. My signal was captured with the by the system or by the AI agents. All right. And based on my signals and based on the signals by other users, we are tracking their behavior and we are able to recommend them other different products. See, now I've clicked here. I have another signal, viewed agentic AI bootcamp, right? And I've been, recommended a different course to take. So we are talking about product recommendation system, all right, an agentic AI application. Now, what I'm showing you over here, we can, now if I'm going over here, production grade systems, and if I just add this to the cart, you can see the signal that I have added something to my cart. All my signals are being captured. This will be passed to our AI agents, and our AI agents would be making decisions that which product to recommend to this particular user, right? So, agentic product recommendation system, right? I can add this to the cart and signals are being cached, right? Now, let us say this is an amazing product. Where is Mesh API coming into the picture? Mesh API is helping this product to not stop at all. Fault tolerant system. If I go to Mesh API console, see what do we see? Real time. Okay. Tokens used today. How many active models? We have 3 models working as a backbone of this particular system, right? Requests are increasing per minute, per second. Latency is being calculated with every response. All right. And see, model routing, we are able to trace which model is giving what output. We can see if Gemini is failing, OpenAI has got its back, right? We can trace everything that, which key signals were captured. People are capturing this more, which is getting more visibility. So we are able to trace everything with the help of this gateway. Okay. We are also able to see live event stream, that which user is, doing what kind of activity onto our system, right? How is the token spending of each of our AI models? We are able to do all this with the help of Mesh API. Okay. Now, this is not the real page, or this is not the real dashboard of Mesh API. Let me show you the real dashboard of Mesh API. This is how the real dashboard of Mesh API looks like. You can see I'm in this particular organization. This is my dashboard. This is the models which I have used. This is the cost involved with those models, right? Organization, team, individual basis. We can trace all of this. How much we have spent in total, how much we have spent in the last days. We can do all of this. And let me talk about the features. Okay, all those features which I was talking about, I was not talking about in thin air. I read the documentation, which is what you will do after this particular class. And let me talk more things about it. Okay, your existing code, our infrastructure, which means we can seamlessly integrate 1000 plus LLMs in our application. Now, this involves embedding models as well. Okay, why this Mesh API is different? Persistent agentic memory. We can use episodic and long-term memory to run our system. We have a built-in RAG system. Okay, we have a built-in class which we can use without even writing the whole logic for RAG building. We have detailed audit log, which we were seeing right now, and we have smart routing, which is what a classic feature is by all the gateways. All right. Now there is something called as smart router, which is provided by MeshAPI. Smart router will automatically choose which model to go for given on the task. Smart routing is where MeshAPI is different from other gateways. All right. So you can see, pick the right agent for your every job. All right. You have all those things. Now, if we talk about the features, you can go through the documentation. Documentation is going to provide you everything. And before moving to the next video, this is going to be your task to go through the documentation properly. Now, what all things are there? We can make API keys. We can set rate limits. We have bring your own keys concept where you can connect with, your favorite providers, Amazon, OpenAI, Bedrock, right? You would see this here as well. Somewhere we would, see the bring your own keys as well. Let me see over here. Real-time integrations. Okay. Lot of things are over here. Okay. API keys, right? You can trace all of those things, right? You also have tutorials. How would you, learn this on your own? Right? Isn't this amazing, people? Isn't this amazing? Routing policies, how exactly they are routing. You can set your own policies, logs, right? Models, so many models. Check this out. You name the model and you have it. Okay. So many different pages, 50 pages. All right. This is not a joke, guys. This is amazing. Okay. And with this, you can connect to Google Vertex AI, AWS Bedrock, and lot of things. Right. Usage monitoring, caching, tool memory. So I recommend just check out all of these things: audio, text to speech, speech to text, right? Now let me go back to our notes and talk about Mesh API a little. Mesh API comes with three things. One is a Mesh API Gateway, which we have been kind of talking about. Mesh API Gateway, right? Which means single key access to 1,000 plus LLMs and embeddings and models, right? We have been talking about this. We know what is a gateway. Mesh API also provides us Mesh API CLI, which means just how you use your Claude coding agent, right, to do your task on a local level. Similarly, you can have Mesh API installed as well, which will use all the Mesh API features to solve your tasks. Okay, just how you run Claude code, you can run Mesh API as well as your coding agent. Lastly, you have Mesh API MCP, which means you can use Mesh API as a MCP server, and you can integrate this in your coding agent where your Claude code or any other coding agent which you use, open code or any other thing, will be able to use all the Mesh API features. Okay, how does that look? Let me show you that. See, just how you can, start your Claude in your terminal. Similarly, you can start Mesh API in your terminal. Just how you can generate images, Mesh API offers you image generative features, right? So you can give the code and you can generate these kind of features, right? You can use your coding agent will be accessing the image generation tasks, right? Lastly, you can do audio generation as well, right? For I was trying to generate some Hindi text, English text, it automatically picked up this server model, which is an Indian model, right? Now, isn't this amazing? And this was all about Mesh API. Now you know what is Mesh API, why we need Mesh API, how it is different from other APIs, right? Error handling, auto router, embeddings, built-in RAG, memory. So how guardrails work in this particular scenario? You just have to simply say that, hey, remember, do not entertain this kind of query in the future. And guardrails are implemented as it is. All right, in the memory itself, so that it will never forget. That is also a unique way to handle your guardrails, right? And yes, that was all about Mesh API. Let me quickly go ahead and set up our project. Okay. This is my empty folder. Here I would make something called as Mesh API. So Mesh API, I have made it. And in this Mesh API, I would go ahead and open this with VS Code. And what we are going to do here is basically we are going to set up our virtual environment, as simple as that. So I'm going to go here and I'm going to set up my virtual environment using UV. So UV, VENV, Mesh API, ENV. Once we have made our virtual environment, let us go ahead and activate that virtual environment. And now our virtual environment is activated. What I'm going to do is quickly, I'm going to install some requirements over here. So let me show you the requirements. Fast API to build our application and UVCon. Jinja 2 for setting up a template, a web-based template. Python multipart just comes in this stack itself. .env to load your environment variables. Mesh API, which is our gateway over here, right? And then lastly, we have Pydantic for structured outputs and request to handle different kind of requests. All right, this is done. What we can do is we can just simply install all these requirements. So uv pip install -r requirement.txt. We have installed our requirements. I would also make something called as .env file. Okay, in this .env file, we would need a bunch of things. Okay, starting with, we would need your Mesh API key. Rest all things I would be adding when it is the right time. For this, you would need your Mesh API key. You can check the Mesh API key docs. Let me go here. You can check the docs. You can check the pricing over here, how the pricing model works, how you can, get your tokens. And once you are in this particular dashboard, once you are in a, once you have done the billing part and you have checked out the pricing part, you can go ahead and, generate an API key for yourself. So I'm just going to click here and an API key would be generated, right? You can just add it, whatever name you want, for the specific organization. You can also, have a spending limit, right? Requests, you can apply all these different kinds of limits, tokens, requests, how much you can spend onto this particular keys before giving this to anyone else, right? And using it yourself so that you manage your spending habits and your agentic habits. Now I would like to say that. And yes, that is all you need for this particular video. That is all you need to set up this particular project. I will see you in the next project where we will start with the experimentation of our Mesh API. We would learn this Mesh API gateway in depth. And to set up our Jupyter notebook, you will write uv pip install IPY kernel, and we can then use our Jupyter notebooks from the very next video. Now we need one more thing over here. What we need is Mesh API base URL, because you know that whenever we use any kind of gateway, we are able to see analytics of these kind. Now to get the analytics of this kind, this means that we have to send our information, our LLM calls onto Mesh API client, right? So in order to send the data to Mesh API client, we need a Mesh API base URL, and this is the base URL. This is where we would be sending all our LLM calls via Mesh API client. All right. Now this being done, let me make a new folder over here. The name of the folder will be experiments, because we would start to learn by experiments first. Okay. So I've made some experiments. I would also add docs for you over here. So first let me add docs as well. And in this docs, when it is the time, step by step, I would go ahead and add all the required information. So for now, I will just add two docs over here. One is research, that what was the research I did on top of Mesh API. So this is gonna cover everything about how would you research for Mesh API, and this covers all the features which I was talking about. There are many features in here. There are good diagrams, section 1, section 2. There are a lot of things. You can check that out. All right. Now let us go ahead and start with the first experiment. What we are going to do is, I will make a file, and this will be 01 Mesh API Basics. Okay. .ipynd. This is going to be the name of the file. We already installed IPY kernel in the previous video. Now I'm just gonna print something random and see if it is working. So this is working absolutely fine. What are we going to do in this particular experiment? We are simply going to learn how to open a client, how to open a Mesh API client, to be very honest, how to close a client, and in between how to, choose a model and send a LLM call to the model. That is all we are going to do. Choose a model and send a LLM call to the model. As simple as that. Because we are talking about the basics. So once the basics are correct, then we can take this up a notch. I hope you agree with me. So for this, I would import some standard libraries which we would need to open a connection. So we are going for the first part, open a client connection, right? Mesh API client connection. We need these kind of libraries, OS, getPass, right? We need .env to load our .env and all those things. Let me open this. Now for Mesh API, we need from Mesh API import Mesh API. So to connect with Mesh API client, you need Mesh API package. Okay. And then lastly, what we will do is we would just simply add a Mesh API get env, right? Get env Mesh API key from the environment variables, or if there is no Mesh API key, you can, ask it as input from the user. Okay. Then what we would do, we would make a client over here. This would be Mesh API client, and we need to use this to make the Mesh API client. What all things are required from here? We need, the first thing we need is base URL, okay, where we are going to hit. So this is again gonna be Mesh API base URL, okay. If there is no Mesh API base URL, this is gonna be the default where we are supposed to hit, okay. And secondly, we need token. So for the token, we would need this Mesh API token, and that's all. That's all how that's all is a standard way to open and hit any client. And once this all is done, it's gonna print client ready. Okay. Now what we will do is, so we can do something like this. This client which we have made, this client which we have just made, now it inherits Mesh API. Okay, so client is gonna have a few methods. See, client.audio, client.chat, client.embeddings. If I just simply click client.models, all right, now I'm gonna get an object. But if I do something like this, models.list, which is gonna list me the models. Okay, see, it's gonna take a second and it's gonna give me all the models which are there. Okay, all the models. You can see different models, Jamba Large, Happy Horse, Quen, Voice Design, whatnot, Alibaba Group. And the list will never end because there are 1,000+ models, guys, 1,000+ models. Now, what I can also do is I can print the length of this particular thing. See, I can print the length and tell you that what is the length of the model. So there are 997 models in this list, right? Similarly, we can do for embeddings. What are the embedding models? Okay, so embeddings is a different way. We'll explore this embeddings part in the next particular video. But for now, I think this is cool. Now you know how to list your different models. So what I'm going to do is I'm going to iterate on all of these models. See, for m in client.model.list, I'm going to iterate on each of the models, and I'm going to just print the length in a better way. That's it. Length of all models. So there are 997 models, which we already know. Okay. Now how to access one of the models? Okay. How would you get the names of the models one by one? Just the names. Here we got something else. Okay. If I remove this and if I remove this, here we got the total information, something like this. Okay. We can perform indexing on this. I hope you agree, right? We can perform indexing on this. So how would you do that? I would just simply click all models by name. I'm just gonna iterate on all the models dot values. Okay, all models dot values. This is gonna get me the list of all the values of all the models. And then what I will do is I would convert this all models by name into a list. I would access the keys and I would access the 0th model. Okay, so if I do this, I can get the first model. What I'm trying to show you is how you can access any model. All right, I hope these things are simple. We are just talking about how would you access a model. That's all. All right, now we know how to open a client. We know how to access a model. Now we would see that how to hit a client. Okay, this is going to be well documented. For now, I'm showing you this directly raw, but this will be well documented. Hit the MeshAPI client. We are not hitting the client yet. We are just fetching things from it. So one best thing about it is MeshAPI. While we are using MeshAPI, we don't need any kind of framework. Okay, and and you would not even feel like you are not using any framework. What do I mean by that? See, from MeshAPI, okay, from MeshAPI, import chat completions. So we have chat completion params, and we have chat message. Okay, what people have done is people have standardized everything in such a way that no matter whatever you use, you should feel that you are doing the same thing. So isn't it a feeling of we doing the same part in LangChain itself, right? Chat message, chat completion, right? This has become a standard way. Now let us get the response. For response, we would go client dot chat. This time from all the methods, I would access the chat method, and dot completions, because we want to hit the client, we would create. Okay, what are we going to create? We are going to create chat completion params, like we can see over here. So I would make chat completion params object over here. What all things it's going to take? First, it's going to take a model. That, hey, what is the model you're going to use? So I will be using OpenAI model. Okay, OpenAI model, and this all is included in pay-as-you-go pricing. Okay, if I take messages, now we want to pass messages, right? So this is going to be very simple. This is going to be a chat message. So I would open a list, and in this list we're going to have a chat message. Okay, in the chat message, again things are so standardized. Role is going to be user. Okay, and then content. We can pass what is it that we are hitting the client with. So I can just simply ask a question that in one sentence, tell me what is an AI gateway. So see, this is so simple. Chat completions, chat completion params, model, chat message, role, user, content. Okay, just how we do it. Now we would have another parameter after this. Okay, after messages we would have another parameter. The name is going to be max tokens, which means how much max tokens we are willing to invest in this particular response. We don't want to give more out of, we don't want to give a longer response than 60 tokens. Okay, because we can restrict that as well, right? We have control governance over our system. Now we can add response dot choices, zeroth index dot message, just standard way of accessing the information, dot content. See, this is how we access in LangChain as well. Now if I would access this, I would get a response that an AI gateway is a platform that facilitates the integration, etc., whatever. We were successfully able to hit the MeshAPI client and get the response. Similarly, if you would see here you would also see the logs. Okay, you have a separate page to check your logs. See, I've hit OpenAI client, and if I just see over here, I can see the exact process, what happened, and etc. Okay, now simple. What now I would do is, now we would see how much cost. Okay, this is the most important part, how to check your cost as well, right? Because people don't talk about this usually. So I would write here usage. Usage is going to be equal to response dot usage, which means whatever response we gave over here, right? From the choices we access the response, the content which it gave, but now we have to access the usage part of it. How would we do that? So I've just made this variable usage, and I'm gonna print usage dot prompt tokens. Okay, this is gonna tell me that how much tokens were used. Okay, we can also tally this from the API. All right, if I go over here, we can see over here that 17 to 38 tokens were used. As simple as that, see? So we are able to get the exact tokens, which is also being synced, right? This was prompt token. Now in a similar way, I can print completion tokens. Okay, why was it 17 to 38? Now I can print completion tokens. 17 to 38. And now what I can do is I can print total tokens. So simply I would take this, I would go here and usage dot total tokens, which means for that particular response. See, usage is an object of response. Okay. And we are capturing everything about the response and usage, and we are able to print the total tokens. I hope you are understanding what we are doing. All right. Now let us talk about pricing as well. What we spoke about was tokens. Cost in terms of tokens. This is what we calculated. Now we can talk about pricing. So for pricing, we can simply take client dot models. Okay. Client dot models. We can access the models dot get. What do we want to get? We want to get the name of the model which we have used, right? Because we want to calculate that, hey, which model cost how much? And I can just say check pricing. What is my pricing over here? Okay. So if I just simply print pricing, see what do I get? Model pricing, prompt USD per token 1K, completion per token 1K, pricing unit per 1 million tokens, prompt per USD. So we have got complete breakdown of how the pricing works, right? So I'm just going to print this in a better way. I'm just going to take this and print this in a better way. Estimated cost of this call is 0.0025. Okay, we did some calculations that prompt tokens into multiplied by prompt USD per million. Then we did some logic that completion token. So you can just check this logic and you can understand because that was per million, right? And for this particular call, we took this many tokens. All right. Now, once this is done, we can simply close the client. Close the client. All right. How would you close the client? You are simply supposed to write client dot close, and it's going to close your client. What do we want to print over here? We want to print that done. All right. Next, we will build RAG. All right. So yes, that was all for this particular video. I hope you learned the basics. We started by opening a client. All right. We opened a client like this, which takes a base URL and a API key. Then we were able to access the models. All right. List of all the models. Please feel free to access different models. Okay. You saw how we were able to access a specific model by indexing. Then we were able to hit our model via our MeshAPI client. Then we were also able to see the cost breakdown, that how do you exactly calculate tokens. All right, then pricing, how do you calculate exact pricing for one call, so you can find out for your entire application how much for one rack call or for one agent run how much it calculates. We're going to go ahead and build a RAG with MeshAPI so that you know how to build RAG with MeshAPI, and we will be using Pinecone vector database for this purposes. Okay, so what I would do is I would add a Pinecone API key over here. Where would I get this Pinecone API key from? I would go here on the pinecone.io page. Pinecone is a vector database. You get a good free tier. Once you log in, it's going to ask you for a few things. You can start for free and you can skip all of this. And you can just simply, you would get a default API key. You can either use this or you can just create an index. You can create a new index. You can also get your own API key. For example, we are building MeshAPI, right? MeshAPI. We can just create a key. You can use this MeshAPI key now, which you have got. And this is as simple as you can read the documentation and you know how to set up your Pinecone then. All right. So that is all we need. We can see create index, what happens. Create index, we can add a name to this index. For example, MeshAPI index. I can just give it a name like this. Llama text embed is going to be the similarity or embedding model which is going to be used in the backend. It's going to be serverless, it's going to be AWS, and we can do all this setup from our code as well. Okay, creating index. See, So there are two ways to do this, from here as well and from here as well. So I would go ahead and show you the developer way of doing it. All right, now simply let me go here and I would just simply paste my mesh API key in my .env. And once that is done, I can just simply make a new file over here, which is going to be 02 rag and multi-agent. We are going to see both of these concepts, and this would be .ipynb. Okay. You can just simply select your kernel over here. I can just print something. If it works, this works. Now we can start building our rag. All right. So for this, the very first part we will do is we'll do the initial configuration. So I'm just simply gonna take the similar code which we have done before. All these libraries, load.env, mesh API base URL, mesh API token, and pinecone API key. I would just simply run all of this, and these all are running absolutely fine. Now we have to set up a few things. Okay, see, here we could have created our index and it was asking for us for several fields, that what will be the name of the index, right? What will be the embeddings model you would be using, and cloud provider, region, what do you want, all of these things. Instead of this, we would stick to this part. All right, we would stick to this part of creating it. So let us see how we can do that. I would go here. I would set up a few credentials. So Pinecone index is going to be this, cloud is going to be AWS, region is going to be this, embeddings dimension is going to be this. And I can simply set them up. Next, what I would do is I would set up my Mesh API client, because we have to do that, right? So this is going to be simple as well. We would import Mesh API. We would connect our client with our base URL and our API key, and then finally run our Mesh API client, which is ready now. Now we simply have to now use models. We have to use models so that we can use them throughout our implementation. So we need three models. One will be a fast model, GPT 4.0. One will be a smart model, okay, Mistral, and one will be a embedding model. Okay, so you would see that for the purpose of embeddings, we are not using from the Pinecone. We are making our own embedding model because we can make it through Gateway. All right. So we always, choose that option which is much more convenient and which is everything at one place. So Gateway offers us that embedding model. Yes, we can make using Pinecone, but using it here, making embedding model from our Gateway itself would be a more convenient way. Okay. Now simple, let us create the completion. So from Mesh API import chat completion params and chat message. For this, remember how we made a response earlier, and in that response we created client dot chat completions, right? So we have not created the client yet. Let me see over here. Okay, client is created. So let me write client dot chat dot completions. All right, and then we can create, right, we can create chat completion params, and inside this we can tell that which model we are using, and model is going to be the model which we have decided, right? Model is going to be the model which we have decided. Now we can say fast model. Okay, but what I want to do is I want to make this simpler. Okay, I want to reuse this particular block of code again and again, right? I hope you are understanding. Check this out. Okay, we will go very slow, no rushing. What we have done is we were able to successfully make a response. Okay, just like this, we were able to make a response, and we were able to hit our client once. We want to have a concept where we can hit this same client multiple times. So what we will do, instead of this, we would make a function. Okay, we would make a function. So the function name would be ask. It's going to take a model as input. It's going to take the prompt as input, that what the user wants. It's going to take temperature and max tokens as input. Okay, then now we would create a response, client.chat.completions.create. Here we would have chat completion params, and then model is going to be the model which is taken as input, messages is going to be a role as user. Prompt is going to be what prompt is getting by user. Temperature is going to be this temperature, max token is going to be this, and finally we would respond the message. I hope you get it. We are making a reusable function. Okay, reusable function which we can reuse for every time we hit our client, right? So this is done, this is created. Now let us select embeddings. Okay, let us select embeddings. As simple as that. For embeddings, I would go ahead from MeshAPI, just how we had chat params, I would import embedding params. Okay, so that we can import embedding models. And for the same task, I'm going to define a function MeshAPI embeddings, something like this, mesh embed. Okay, this is going to take only the texts, which means whatever the data is, it is going to take that as input, and the response. Okay, the response is going to be client dot embeddings dot create. Okay, so you see how we create embeddings. Now once this is created, we would go ahead. In this, we would pass embedding params. Embedding params would similarly take a few things. Model. So here I can say my embedding model. Okay, which we have declared, sorry, like this, which we have declared already. Then input is gonna be texts, which means whatever input is coming, the data is coming, that would be there. So instead of this, I would write texts. And then dimension is gonna be embedding dimension, which we decided. All right, these all things we would be defining. And finally, what we would return embeddings for each of the text. Okay, we would return D for embeddings in each of the text. Okay, and what we have made, we've made a mesh embed function which would inherit or which would take an embedding model. This is the embedding model which you have decided, and this will be the dimensions. We can just run this function, and let us test this function. So I would make a vector, and for this vector I would use my function mesh embed, and in mesh embed I would pass a list of messages in which I will pass hello world, and we would pass this at the 0th index. Okay, and now what we can do is we can print the length of this vector similarly. Okay, so we are able to see that this hello world is converted into 1024 dimensions, which is amazing, right? So what we have done, we have successfully set up a method to hit our LLM model. We have successfully created a method to hit our embedding model. I hope you are getting the simpler versions. Okay, now we would set up our pinecone. Okay, now we would set up our pinecone. So what do we need from pinecone? Firstly, we'll have to do some installations. Okay, so to do some installations, I simply would need pinecone. So I can go here and I can see what do I need. I just need pinecone. I am going to install pinecone. So here uv pip install pinecone. Pinecone would be installed. Okay, now we can just simply set up pinecone. For that, I would write import pinecone first. So, or not import pinecone. First, I would import time to also check how much time it takes. Then from pinecone, okay. Then from pinecone, I would import pinecone and serverless. Okay, serverless specs, because we this is the from standard documentation. Now I would make a pinecone API key. So pinecone API key like this. Once this is done, I would create a pinecone index in this manner. Check this out. I've just picked it from the documentation. Pinecone index name. It's gonna pick from all the index name. So pinecone index name, embedding dimensions, cosine, okay. And the cloud is gonna be this, the region is gonna be this. If you are concerned that, hey, what is happening? So remember, we set up all these things earlier. MeshAPI demo, knowledge base, AWS, US East, and 1024. So To set up a pinecone index, we need a name, we need embedding dimensions, we need the metric, and we need the cloud and the region. Okay, once this is done, we can just simply write index. Index is going to be pinecone class which we have made. It's going to take the function index, and here we are going to write pinecone index name. And then lastly, we can just print that index. We can just print describe index, then describe index stats. Okay, we would run this function and let us see if we get something. Okay, and let us also see if something happens over here. I can hit indexes. Okay, let us refresh. Possibly we should see an index over here. See, MeshAPI demo knowledge base. We just created this index. We can connect it. Okay, to connect it, we just need an API key, all that which we already have, and see, we have successfully created a pinecone index. All right, now let us add some data. Let us add knowledge base. I'm just gonna add simple documents. ID, document 1, title is refund policy, and then we just have some text that Nimbus Cloud offers us this. All right, we are just making a policy agent kind of scenario. Data retention, text. All right, this is some data. You can definitely check out, read it once so that you know what is the data. I would just embed this into my vector database. That is what I would be doing. Now, since we are not using dependency of LangChain, all right, so the chunking part which we have to do, chunking is the next part of the RAG, right? So the chunking part which we have to do is going to be manual in nature. So for this, I would define a function, chunk text. It's going to take a text as input, just how embeddings were taking text as input. Max characters is going to be 500 and chunk overlap is going to be 50. We would create an empty list for the chunks. We're going to start at 0. Okay. The 0th chunk, we are going to start, we are going to calculate the length, and in the similar way, we are going to get the chunks out. All right. Once we have all the chunks, we are going to iterate for each chunk and we are going to embed this. All right. So see, we are going to check each chunk once they are broken into 500 characters and 50 overlap. We are going to append all of these chunks in this particular empty list. And once this is done, we can just see the length of the chunks. So we have created 8 chunks from 8 documents. See, for each chunk we have calculated or fetched the doc ID, title, chunk index, text in a standard and a structured way, right? We can see all of this, which we are able to see, right? Now what we can do is, we can take all these chunks and embed this. All right. Once we embed this, we can push this to our vector database, right? That is what we want to do. So how would we do that? First, I would take embeddings. All right. So I would just make a variable embeddings. Okay. Let me fix the spelling. The moment I've made this embeddings, I would use my method which I can reuse. All right. And I would take, for C in chunks, I would take all the chunks. Okay. And here I would access C text. Okay. I would access the text of all the chunks. Okay. I hope you are understanding what we are doing. And I can make a list like this. This is going to be a list. And in this way, I can extract all the embeddings. You can see embeddings now. Or we can just print length of embeddings. We should be able to see 8 embeddings, right? So we can see 8 embeddings, as simple as that. Now I can just simply convert this to pinecone vectors. Okay, we can take the ID, we can take the chunk, we can take the values of the embeddings, and we can just feed them into our pinecone, right? How do you exactly do that? So you write index.upsert. Okay, that is how you insert values in pinecone. And what would you pass? You would pass vectors is equals to pinecone vectors, because we have structured our vectors in a way that it fits pinecone indexes, right? And this is done. We can just simply print that indexes have been upserted with this particular length. And once we do this, it's gonna upsert, and we can see the same in here as well. Okay, once I go inside this, currently we can see all our 8 documents successfully, right? Now, isn't this amazing? The embedding model is of our gateway and vector databases Pinecone. I was showing you how do you connect that. Now we have successfully completed the data ingestion phase where we had our data, our knowledge base, we made chunks, we made embeddings, right? And then we also loaded this into our Pinecone vector database. We are done with this. Now we are going towards retrieval part. We will retrieve our data. Okay, how do you retrieve your data? I will just simply make a retrieve function, retrieve, which is going to take a query and top 3 as input, which means how much top chunks you want to get. A new user query is going to come, which is going to be embedded. These embeddings are going to be converted into a query, the new query which is coming. Okay, this query is going to be compared with all the different vectors in our vector database. All right, and then finally we can run this. Okay, so I can use for R in retriever. Okay, for R in retrieve, I would once this is done, for R in retrieve, I can just simply pass how much storage do I get on the pro plan. Okay, I can just make this query simply, and inside this loop I can just pass what are the results. So let me show you a test query how it would run. Storage limits, we got the response, we got the first metric, we got the second metric, and we got the third metric, which means the most similar ones we were able to fetch in this particular way. Okay, now what we would do, we would make a plain RAG. Okay, still there was no LLM involved over here, please understand. I was trying to show you vector search. Let me be very specific. Vector search, that is what we were seeing over here. Okay, now this is done. I would just create a plain RAG. Okay, how does this plain RAG looks like? I'm gonna make a helper function RAG answer. It's gonna take a question, now a model, and the top k as input. We're gonna use the retrieve function to get the top similar chunks. We are going to join all of them. We are going to pass them in this particular context, that answer only from this particular context. This is the question. Ask method we used, which will take a model, a prompt, temperature, and max tokens as input. Okay. Hits is nothing but similar chunks which we have fetched. So answer and sources are going to be retrieved from RAG answer because that is what it's going to return. And what happens if I go over my storage limit and see how we would get the response? We get the answer and we would get the sources. So this is the answer and these are all the sources from which it is responding. So I hope you know this is how a RAG works and this is how we, carefully extract things, right? Carefully extract the relevant documents. Given this, okay, this is how you would make a simple RAG, right? This is how you would make a simple RAG using your gateway. Now we would make an multi-agent system. Okay, this is going to be interesting where we will reuse this RAG in the form of research. We are going to create a multi-agent system and the flow is going to be pretty standard where we would have 3 agents. Now how these 3 agents are going to work is, first is going to be the researcher agent. Second is going to be a writer agent. And the third is going to be a critique agent. Okay, so whenever we try to test multi-agent workflows, we develop in this format. Okay, critique agent who is going to criticize that what the writer has wrote. And this is how a standard content development team also works. All right, so what we are making is 3 agents, content developers. All right, we are using this and we would also have a way of reusing whatever we have made earlier in the RAG. Now let us understand one part. I taught you how to build this RAG independent of LangChain. Okay, independent of LangChain. But can't we use LangChain? Yes, we can. and we would use Chat OpenAI for this, because Chat OpenAI gives us a standard OpenAI compatible, okay, standard OpenAI compatible method to hit clients, okay, chat clients. That is what Chat OpenAI gives us. So we would use that. For this, I would have to go ahead in my requirements and I would have to update my requirements. Now there is no LangChain I can see over here. So for this, what I would need LangChain OpenAI. So LangChain OpenAI, okay, and I would also need something else. Let me quickly see that. Okay, apart from this, I would also need the tool decorator, so LangChain tools, but I think we are fine with this. And I think we need LangChain community as well, so I can add LangChain core and LangChain community. So LangChain core, okay, and LangChain community. I would go ahead and install all of this. So uv pip install -r requirement.txt. This is going to install all these different packages. So I'm trying to show you that how you can also use LangChain, all right, to build all of these things. We would just simply continue this notebook from LangChain, okay, from LangChain underscore OpenAI. This would be the method. I would use Chat OpenAI, okay, Chat OpenAI. This is what we would be using, okay, the method from LangChain. Let me check if it is installed. Okay, it is installed. I can just simply run this. Okay, it should not give us any error, hopefully. Chat OpenAI. All right, it has become green, so I think we are good. Now what I would do is I would also make up a MeshAPI OpenAI base URL so that it is compatible with OpenAI. Okay, once this is done, I can also run this part. So let it run, because it is just installed, it is taking time as well. All right. Okay, it is giving error. I can just run it again because it was first installing, right? Now it is done. Now I can just simply copy my fast chat. So I can make a fast chat. See, what do I mean by that? You remember we had fast model and slow model, not slow model, smart model, fast model and smart model. So what I would do is fast chat, I would make Chat OpenAI. I would make this client. It takes two things. First one is a base URL, just how every client takes. I'm going to pass MeshAPI base URL, or instead of this, MeshAPI OpenAI base URL. Okay. Then it's going to take API key from us, that where are you hitting. So for this, we would use MeshAPI token. All right, because we are using the MeshAPI key, and we have to specify model. Okay, model, we would use the fast model. This is the fast model, right? This is the fast model setup. Similarly, I can set up a smart model. Okay, so for this, I would make a smart chat. Okay, smart chat, and this would take the smart model as input, nothing else. Okay, we have successfully set up our fast model and slow model. Now I can just simply print that LangChain is being wired to both of my MeshAPI models. As simple as that. Okay, we have already created it, and now we are using MeshAPI just how we have used it in other gateways using LangChain. All right. Now what we would do is we would create a tool. Okay, what this tool is going to be, search knowledge base. This is the kind of tool we want to make. So for this, we would import the standard libraries JSON and tools, tool decorator, and I would just simply make a tool function. So tool decorator is going to convert any function into a tool. This is going to take a query as input. It's going to run my retriever function, which takes a query and gets us the top 3 or the top k chunks, and it's going to return the json.dumps hits, which means whatever the similar vectors were. All right, so this becomes it. All right, now what we can do is we can make a researcher agent. Very simple. Okay, researcher agent, how we would make it? So from LangChain underscore, from LangChain dot agents, I would use this part. From LangChain dot agents, I would import create agents. Okay, now I can see that there is no LangChain, so I would go ahead and I absolutely forgot to add LangChain in the very first place, and I would again hit this command so that LangChain would be installed. Once LangChain is installed, let me see. Okay, LangChain is installed. I can just run this. Okay, and for researcher agent, how can we create a researcher agent? Researcher agent is very simple. We just have to use this create agent method. This takes a few things. First, it tells us, hey, which model do you want to use? So we would say we want to use the fast chat model. Then it's going to ask us, hey, do you have any tool? So in the list of tools, we can give the search knowledge base tool, which we just created. And finally, system prompt. The system prompt is going to be a little bit lengthy. Okay, I'm going to make a triple quote string. And here I can just give a few commands that, you are this, you are this and that. Okay, always use the tool and answer before answering. Okay, I can remove all of these in between. See, like this. And do not answer the user questions directly. So I've added my system prompts given how my agent should behave. All right, this is my researcher agent. My researcher agent is always going to research from my vector database, which I have created in Pinecone. Okay, now we can just simply run this researcher. Run researcher, it's going to take a question as input. It's going to invoke our researcher agent. We can invoke our researcher agent for the messages. Role is going to be user, content is going to be question. Simple, compatible, OpenAI compatible chat completions. Okay, we have done this before with MeshAPI. So researcher agent is ready. Similarly, what we can do is we can make a writer agent. So writer is going to be a smart agent, smart chat, and researcher is going to be fast chat. Okay, you are a helpful support agent for Nimbus Cloud. Use this research nodes what the user gives you. Only write from what the researcher agent is giving you, nothing else. Then we program our writer agent who takes the question and the context. It's gonna give us the response. So writer agent is set up. Okay, I can just simply write writer agent setup. Now I would add critique agent. Critique agent. Okay, now critique agent is gonna give us structured critics. Okay, structured critics. So for this we need Pydantic import base model, so that what we can do is we can imply, okay, we can imply validation on top of this. What is the critique? What is the class critique we are making? It's going to take the verdict. Okay, pass or revise, which means whatever the writer has written, should we pass it? Are we good, or should we need revisions? Reason, why should we pass or why should we revise? Okay, what is missing? That is, there is missing anything? Okay, so you are able to see that how in a structured way we are getting critiques. All right, now once this is done, I can just make a critique agent. So create agent smart chat, it's going to take. You are a quality reviewer for customer support answers. Grade the draft strictly. Okay, fully and accurately answer the questions using reasonable support agent knowledge. Okay, the response format is going to be critique. Critique is a Pydantic class. Okay, complete AI governance is coming into the picture slowly. Run critique, it's going to take a question and the draft by this writer, and it's going to give us the critiques. Finally, what we can do is we can orchestrate all the agents in one. How we would do that? Okay, we would simply make a function, define research, write, and review. It's going to just take a user question. It's going to tell us what was the question. First, run researcher, which is going to give us some notes. Then run writer. It is going to take these notes as input and it's going to give us a draft. And then this critique agent is going to run critiques on the question and the draft. And then we are going to get the final draft in written. Okay, Now what we would do is we can make a variable final, which is going to be the final response, and this is going to take the method as research write review. To this, what we can do is we can just simply pass a question. Okay, this question can be as simple as, if I cancel my plan, okay, if I cancel my monthly plan halfway, do I get the money back? Okay, this is the question, and we can just print the final answer, because of course this method is going to do everything. Print the final answer. So see, if I cancel my monthly plan halfway, do I get my money back? Now what we will do is we will be able to see the entire trace and the critics. So researcher gave us all these from the vector database. Great question for the annual plans. So the writer has written the response. Critic agent thinks that we should revise it. The reason that draft accurately addresses the question about refunds for canceling monthly plan. It clarifies that no prorated refund is provided. So whatever critique it has given, we can truncate this as well. And then finally we get the answer. All right. Now we can try our own questions as well. Different question. Is two-factor authentication required for the pro plan? Right. We can do all of these different kind of operations. So what I am trying to show you here, how can you make a multi-agent and a RAG system using MeshAPI? Okay, now we can just do the final cleanup. We can just do client.close. We can close this client. Okay. And once the client is closed, we can print done. The client is closed. Okay. I'm going to go ahead and have a quick tour of all the features of MeshAPI. See, this is the files. We are going to have a MeshAPI feature tour. See research.md and features.md to understand how this notebook was developed. We can have a good understanding of all the chat and embedding models, free models, paid models, image generation, video generation, audio generation models. We can have, we can play around with all of these things. We can learn about bring your own keys concept, MCP server, Go SDK. We can understand all these things. Okay, so for this, let me go ahead and first see if the notebook is working fine. So if this prints, okay, this means the notebook is fine. What we can do is, firstly, we need to import a few starters, right? We need to import our MeshAPI key. We need to import some. So MeshAPI also gives us a way to handle errors, MeshAPI errors. Okay, this is very important to know. So this can instantly raise errors, all right, in the exceptions. So this is great part, MeshAPI error. Okay, you can read about it. Raised when MeshAPI returns a non-2xx response on a midstream error, right? We are going to go through all the basics. So for that, first we'll have to set up our client. To set up our client, we need MeshAPI base URL, MeshAPI token. You already know this. We would pass the headers in this way. Okay. And we are writing a helper function over here. What is this helper function? So this helper function is called show. This function is going to take all the responses and give output as a JSON object. Okay, if it is not already. And once we are done with this, we can just print this that the client is ready, right? Now we will go through each of the features one by one so that you understand each part. You have seen this before. We set up a fast and a smart model. So we have set this up. You can change this model, of course. Okay. And if we are also concerned, so we can see all of this analytics being happening over here as well. Okay. You can trace everything which is happening here. All right. Now the very first concept which we already know is chat completions. We import chat completion params, chat message, and we use our client to complete our chat. This you already know that how we can, use this chat completion params, which takes a model, messages and tokens as input, and it can gives us a response. So what is AI gateway? What is AI security? We can ask. So what is AI security? And it will give us a response in 60 words. So see, it is giving us the response, measures and techniques implemented, etc. Now let us see something called as streaming. All the chat models which you have used, OpenAI, Claude, etc., these all by default gives us streaming behavior. So see, chat completion params we would use, and here we would use a stream method. Not a lot will change. Okay, see, things will be the same. Dot create chat completions. Instead of this, we would have dot stream. Okay, what is stream? You would see the output. Okay, we would pick the each chunk given by our choices, which means the response, and each chunk we will print as soon as we are getting the response, which is what flush is equals to true. So now you would see an incremental way of response. Okay, I can make this 10. See, I hope you saw that. That was an incremental way. Now I can make it up to 5. And see, incremental way, right? Streaming way. Very simple. We know streaming, right? Now Mesh API also offers us a way of tool creation. Guys, this gateway, Mesh API Gateway, how it is standing out is it is helping us to be independent of any framework. That this is all you need. You need models, come to us. You need embeddings, come to us. Okay, you need to convert your functions into tools, use our functions. Okay, so from Mesh API import tool and tool function. Remember how we use tool decorator in LangChain? Similarly, we use Mesh API over here. Weather tool is going to be tool. Okay, type is going to be function. Okay, because we are making a function. Function is going to be tool function. The name is going to be get weather. The description is going to be get the weather for a city. And parameters are going to be in this particular manner. Just how we pass the standard JSON type of parameters, right? Which is going to be type, properties, and required city. Okay, these all things are going to be required. Now what's going to happen is response chat completion is going to create a new chat completion. You can either stream it. It's going to take a fast model as an input. Messages are going to be simple, just how we have the standard messages, right? Then tools we can also add, just how we can add a tool in our create agent method in LangChain. We can have tools over here as well, weather tool. Tool choice auto, which means if there is a need, then use the tool or else no. Max token is 100. And then we can just call this. Okay. We are asking what is the weather in Paris. So see Paris and we know the weather. All right. So let us see how it can give us the response. Call dot function name, call dot function arguments. Okay. Let us see. Model wants to call get weather with city arguments at Paris. Now this did not work because we have not created that function yet, right? Right. Name is get weather, but we have not created get weather anywhere. All right. We have just converted this into a tool. We'll have to write a function. Okay, we'll see that upcoming. But we know that the moment we call this, we got to know that the model has called these both things in this particular structured way. Okay. Now let us explore the structured outputs. We would be using Pydantic for this. Pydantic, let us say country. So country, capital and population in millions. We are getting this as a standard validated class. Okay. We would run this. Model we can pass, messages we can pass just how we have been passing messages. Response format is going to be this. See? Response format is going to be JSON schema. Name is going to be country because this is the class which we have created, right? And schema is going to be country.model.json.schema. Okay. And when we use this country model validate JSON, this is how you would run this particular chat completions and see how the output is going to be like. You would see country is France, capital is Paris, population is this much. All right. Now you can compare two models. Okay. So for that Mesh API, we have compare params. So now we always have to decide, right, that which model to choose for which task, right? So we can use compare params, that how they are performing on a similar task. So we have compare params. So not all of the frameworks give this. Okay, this is how Mesh API is different from others. So fast model, smart model. So you, in less than 5 words, what is a gateway? Okay, it's going to give us both of their response. Show result. Okay, show method. It has given us both the response. Okay, we have not captured it. We wanted to see the whole thing. So see comparison ID, comparison completion this time, not chat completion. Two models are involved. Results. OpenAI gave this body. Okay. Content access point to networks. All right. This is what it gave. Access point to network. So remember how we capture the 0th index and from that we capture the first message. That is what it is all about. Okay. That is how we exactly capture the response. Okay. Then usage, you remember how we were able to calculate usage, right? Then content, you can access anything basically. Now I'm taking you in the depth that if you simply print the response, in the response you will find everything and you can capture everything specifically. Similarly, we can also check the response for other class. See Mistral. What is the content given by Mistral? Okay, we can scroll down, prompt, access point. Okay, this was the content given by Mistral. All right, and this is the comparison. We can use all of this to compare the models. Then we have something called as model discovery. We have list of all the models, and from that we will also list the free models. So client.models.free is a method to see which are the free models available. Total we have 997 models, but these are some free models as well which you can use. OpenAI moderation latest, Tencent, and Minimax. These are good models, but when I was trying these models, okay, some of the models does not support tool calling, and some of them do not also support there was some parameter I'm not able to recall. They were not able to support that. Okay, they do not support image generation. Okay, they do not support streaming. So there would be some parameter. If you try, you can take this as an assignment, that when you use free models, okay, where is it? Let me go here. When you use free models, you would be able to see that you are restricted by something. Okay, please explore that part. Then we have error handling by MeshAPI as well. You remember we imported MeshAPI error in the very initial imports. So chat completions, first we are saying that there is not a real model. We are not passing a real model. We are trying to fail our system. Okay. Hi. If there is an error, okay, see, it will catch it. This model is not supported. It is invalid. So see how exactly it caught the error. The error was on model. Okay. So e.status, MeshAPI error as e, just how we handle exceptions. E.status and e.error code is going to give us that, what is the status and what is the error code. I hope you're understanding, and I hope you like the simple basics. These are software engineering basics. Okay. From MeshAPI, we can input response params. So we can get response in a certain way, JSON type of objects. And this is also very simple, model and input. Say Pong in one word. And when we run this, it's going to give us the response. Okay, response params is also something. So you can explore that how response params is different from chat completion params, right? When do we need this, right? Then here comes an important and an amazing feature, auto router. Okay, depending upon the task, the model is automatically going to route your request to the respective model which will be the best in that scenario. Okay, so I can just break this down in this way. All right, and let me also do this. Okay, so from MeshAPI import router selector params. Choice is going to be client.router.select, and here we would use router select params. Okay, it's going to take a chat message and we are going to write a haiku about ocean. Okay, now here we would say what would the model will pick. So from the choice we can access the model. Let me show you like this. Let me break it down for you. I can do something like this. Okay, I can just take this down. I can just select all of this. Okay, I can take it to the next cell. Here I can just simply show you that how it would select from 997 models. This is the best part. It automatically picked Claude haiku. Okay, we can just simply write something else as well. Write a story about the ocean. Let us see which model it is picking. Again, it is picking Claude haiku model because it is fast. Okay, think a story about birds, or let us say research a story about birds. Let us see how it works. Again, it is picking this model only. No worries, it is doing for fast tasks. Okay, so chat completions.create. This time we would use chat completion models, and here, so remember how we used router selector params. Instead of this, here we can pass a simple parameter. Model is going to be auto. Remember in chat completions, we always specify which model. Here we are saying auto. Okay. And what is 12 into 8? Just the number. Okay, model actually picked which model was picked and what was the response. We can see that, let us say what happens. Again, it picked up Claude Haiku only. Reply will be 96, and this were the total tokens, right? We successfully complete the first part of understanding, talking. What we understood was, let me take you here. We understood talking to the models. Now we would understand the retrieval and memory part. You know how to pick up embeddings. So from Mesh API import embedding params, we can pick up our embedding models. Okay, we can print it. So vector length is 256, first 5 numbers. So what we did nothing. We just embedded a given text, hello world. We just embedded this text into this dimensions and we printed the vector length. Okay. Now, this is also one of the important features of Mesh API, where Mesh API offers us a built-in RAG, right? Built-in RAG. Now, what is built-in RAG? Which means you don't have to use or write anything. Upload documents, Mesh API is going to automatically chunk, embed, and store them, and you can search on top of those documents. Okay. Two things worth knowing while we were testing this. A single short document stays one chunk no matter how many paragraphs it has. Please understand this. If you pass a single document in many paragraphs, it is still going to be considered as one chunk. Okay. There is a size floor between Mesh API, how it splits it. Okay. So we'll do that. You can read this that, rack store is account wide, no delete endpoint. Okay. So see this import time. So it is a feature, but when I tested it, I really did not enjoy it so much, but it is also a feature. Import time from Mesh API, you can use the search request. Okay. I have created some documents like earlier, billing, support, okay, all these different documents, that this is the metadata and this is the actual content. File IDs, we are just organizing them in good, structured documents. We are iterating for each file and we would embed it. Okay, we would embed it. Okay, and then finally we can do rag.search. See how these things work. Okay, first we would import from Mesh API import search request. Okay, we have docs. What we would do is from client we would use a method rag. Okay, just how we have different methods, we would use rag. We would upload a file. There would be a file name, there would be a MIME type. Okay, MIME type. Let me do something if I messed up. There would be MIME type. There would be content, okay, which we would encode and embed true, which means it will automatically perform the embedding. Then we just simply have to take the file IDs and upload in the file IDs using the upload method, okay, which we have just created. It's going to iterate for each of the file, client.rag for each of the file, okay. And once it is ready, it is going to print, and then we can use rag.search and the search request, which is going to search about this particular thing and it is going to give us the response. So let us see how it is giving us. See, uploaded 10 documents, it would, do all the processes for each of them and it would give us a response. But I feel the response was not so satisfactory. We can wait to see the response. Okay. Similarly, until this is running, because there are multiple documents, we have also made a tiny doc. Just how they were multiple docs, this is a tiny doc. Okay. And this is so simple. See, rag in one line. Create client.rag upload file. Okay. This is the name of the file. This is the MIME type. This is the content. Okay. Embed is going to be true. Uploaded file. Again for the each, and same search request, refund policy, and we can see the similar chunks. Okay. Similarly for here as well, we would see uploaded 10 documents, embedding status ready for each of the document. This is the most similar chunk which we have retrieved. Nimbus Cloud offers us guarantee, etc. Okay. So I hope you are able to see this search request. Okay. It is searching for us. Similarly for this as well, it searched the most similar chunks and it gave us the response. But see, this response was not the best, right? This was the second chunk and look at the third chunk. Okay. This was not the best response, but okay, no problem. Let us see the memory part, the guardrail feature. Okay. So currently we we do not have that kind of feature. You can read it in the research, but very simple. How do you import that? You create a request to the Mesh API URL and you hit the memories client. You pass in the headers. And how do you exactly add guardrails is, you create a slug and you add demo guardrails bucket. Okay. What you can do is, about this memory part, you can explore in the research part and you can do it. Okay, this is a little bit trickier. We would come to this later on. Let us come to the good part, image generation. Okay, we have to import base64 to convert images. IPython display import image, show image and display image. So we are using this package. And from Mesh API, we are simply using image generation params. Okay, we can choose an image model. Then from client.images generate, simple generate method. It's gonna generate. We just simply have to pass a prompt that an airplane above a cloud and it's writing Krishna Academy on the cloud. Okay, so this is what I have done. Model is gonna be an image model. So let me do this. Model is gonna be an image model. N is 1. This is the size and response format is this. And in this particular way, you can do the encoding. And once this all is done, you can see image generation. Okay, image would be generated. Similarly, you can do image editing as well, where from Mesh API, you can use image edit params, where you can access a particular image which you have created. And you can say that, hey, this is the image path. This is the image model. What is the operation? I want to remove background. Okay, I want to remove background. So whatever image, let us say this would generate as an image, right? What we would do is we would edit this same image and we would remove background from it. Okay, and it will save the generated image. So here also it will save the generated image. See, it is creating this for us, Krishna Academy, right? Now similarly, if I run this, okay, we saved it, right? We saved it with a name. So let us see, generated airplane image. We saved it with this URL. This same will be passed. Okay. All right. This is something else. We will have to recreate it, I guess. Let me copy this path. Okay. I think this might throw us an error. I will take this. All right. All right. It just took it. So see, it was able to remove the background, right? It was able to remove the whole background of the blue sky, and we have it. So see, image editing can also be done. Then we have video generation. We can use a video generation model. Okay. And again, generate video generation params. We can pass that. Model is going to be video model. Content is going to be video item. Text. Okay. A small girl in a red skirt waving hello Krishna Academy. Okay. So we have done this. So you can make this video as well. Okay. You can capture each frames from the videos retrieve method and you can, make a video. So I will not be creating a video to save my tokens for now. But yes, you can create a video as well. This code will absolutely work. Okay. Then you can have text to speech as well. All right. Text to speech. So you can use this audio method. You can use speech params now. So for every task, you have some params, right? Then you use a text to speech model. You can explore this from the model list. Okay. And you can explore this also from the documentation if you are, worried. See, we are able to see all the traces. Documentation has it all. Okay. Documentation is going to tell you exactly that where to look for what kind of things and what models do we have for what kind of operation. Okay. Let it load. It will load in a bit. Until then, we can continue here. Okay. So we can just create speech bytes. Client.audio.synthesize is the method. Using this, we can, give us an input that what is it that we want to text to speech. And we can do this. Stream is going to be false. We don't want to stream it. We want the exact output. And once we run this, we should have a speech. See, we have a speech. You can play this and you can hear it. It's going to be fine. Okay. Similarly, speech to text. So the opposite of that, we can use 11 labs model and you can run this. You can open the same file. You can access this same file and, client.audio.transcribe. And for this, we are using transcription params. I hope you are understanding that how easily Mesh API has made it for us to, access all these methods, right? Now, if we do this, Mesh API is a gateway for many models. This was the original text. See how we got this input, okay? And we also got it into text, which means audio was correct, okay? We have audio translation as well. So we can translate from one audio type to other, okay? Audio translate model, file name. So we can translate our model as well, right? And it's still gonna give us the translation, right? So this is nice audio translation params. You can use OpenAI Whisper. This is amazing, right? Then you have real-time speech. So client.realtime.connect, you can use this model as session, and you can speak with it real time. Okay, real-time session opened and I closed it. All right. So that was it about exploring these different features. Now let me talk about safety and moderations. Okay, that is why I skipped that guardrails part earlier. How guardrails work is, if you want to know how guardrails, okay, how guardrails work. Guardrails is integrated with memory. Okay, guardrails is integrated with memory, and what you do is you say, remember, you will not tolerate off-topic questions. Now this will be stored in the memory of this particular framework, Mesh API. Okay, it would be stored in the memory, and from memory the guardrails would be enforced. This is how that guardrails part work. Okay, that was not the best demo, but I just wanted to tell you. So we have moderations. Okay, moderations is going to detect the intention of the message. So see, client.completions we had. So now we would use moderation params. If I say I want to kill someone, okay, and I pass this print flagged, and this results dot flagged, it's gonna flag us, and it's gonna give us that, hey, this is flagged. Okay, if it is flagged, we can do something. We can report the user, or we can do something with the user. So see, harassment. If I say if I want to marry someone, okay, this time this would be different. False, no categories. I want to cheat someone, flagged, it's false. Okay, illicit, right? I want to help someone, so see, not flagged. So it detects the intention. These moderation parameters are going to detect the intention, so that you can have a safe environment for your application. You understand that everything is integrated in one place only, right? Now automatic retry and fallback method we have. We can use the request post method. We can use the completions, and it can fall back to whatever model you have put as fallback. You can test that. Okay, I have not tested it. You can test that. Then response caching. For the similar kind of response, it's going to miss, or it's going to hit it. So if we pass a similar question, for now first question was missed and second question was hit. So see, first question will be missed and second question will be hit. But if I run this again, both of them will be hit. See, which means caching is also working, and everything is being logged over here. And this is the documentation. You can see the memory part. You can see the tool calling, structured output, web search, speech to text. You have everything. See, you have everything to research, and how I got to know about all of these codes, right? Let me go back here. Cache is hit. I was trying to tell you that everything is being, you know, stored over here. Okay, you can always trace it. All the logs which you are seeing, see, everything is being stored over here. Okay, we are able to see everything, that whatever we are using. See, we used whisper model, so we have whisper model, it was a success, right? We use this Kokoro model, right? It is success. Moderation latest, we are using omni moderation internally. So see, isn't this amazing, right? Now we are also able to see the cost breakdown, that which are used. If I just do it in the last 24 hours, so in 24 hours I have used these all, right? I've used these all models, right? So I hope you are understanding. Now let me go here. We can do batch processing as well. instead of passing one input, we can pass batch inputs. So see, say A, say B, okay, whatever the response is. So we can pass the inputs in batch as well, batch processing. OpenAI model is being used, and it gave us the response. Similarly, we can make prompt templates. So that is template params, prompt templates. Okay, you can see how we are getting an ecosystem, okay, for each of the task. So create params, name we can just call it any. You are a pirate, speak like one. Okay, we have made a prompt template over here. This is the fast model. Okay, and secondly, we have also created another thing that tell me about her services, company Acme. Okay, and if I print the responses, see, this is the response we are getting, ahoy. So it is talking like a pirate, right? And we are getting all of this, and you can see how it works. Next, we have web search. Okay, web search params. So client.web search, we can just web search what is a AI model gateway, max results. So just how we are using this, we can see this. Okay, and we can also see the sources. So I hope you are understanding that web search is also given, which means they are trying to tell that, hey, you have everything over here, you don't have to go anywhere. See, if I run this, okay, it researched this for me. I can go and check the logs over here, that what was used internally. Perplexity search was used internally to get us the response. Okay, and on the dashboard we should able to see perplexity search over here, and this is the cost. So costing is also pretty cheap, it is good. Okay, accounts billing balance. Okay, I have already shown you how to get balance. So this is my total balance which I have, $37 I have available USD, right? You can also apply limits. Okay, you can also apply limits. So when I would be creating my API key, see, create a API key, I can apply a limit over here, that this much will be the limit, this many RPM requests per day. I can enforce limits on top of API keys, right? So yes, you can explore all these features. These are amazing. Okay, we have almost come to the end of the notebook, and yes, this was it about exploring all the features of Mesh API. Now there are more of them which you can explore on your own. I have given you the notebook, you can explore that. You have all the Mesh API to yourself, you can explore all those features, right? Now let me take you here. Remember, in the initial video, I told you that Mesh API has three things: Mesh API Gateway, Mesh API CLI, and Mesh API MCP. In this video, let us explore the MCP part. Okay, what is this Mesh API MCP? It gives your Claude Code agent the superpower of Mesh API. Okay, let us see that in action. I'm just going to open my code. This is our code, right, which we have done. Now here I can open my Claude code over here. See, this is my Claude code. I can just check hi, and I can ask that, hey, do you have any MCP for Mesh API? So see what it's gonna say. It's gonna say that, hey, I don't currently have any MCP for Mesh API. Okay, so see, it's gonna tell you that, hey, I do not have it. We'll wait for it to respond. Okay, I know for sure it does not have it, but we'll just wait so that it tells us that does it have. There is no MCP server. Okay, there is nothing. So it is proof that there is nothing. What I would do is I would add two things. Firstly, there is a mcp.json.example. What you have to do is you just have to make your own mcp.json. So this is your own mcp.json. In this, okay, you would add your Mesh API base URL, and then you will have authorization, and after bearer you will add your own API key. That's it. Okay, that's it. Once you add all of this in this particular file .mcp.json, what's going to happen is you can reload the window. Now I'm just going to press reload so we can do the developer options, right? Reload the window. If I just reload the window and now I ask, see, and now if I ask, do you have any MCP for Mesh API? So see, this coding agent is going to just tell me that, hey, I do have a MCP and I can do all of these things, list models and all of those things. So I can say that, hey, generate an audio saying MeshAPI MCP is amazing. Okay, something like this, and store this in a folder called as outputs. So see, what it's gonna do is it's gonna make a new folder outputs. It's gonna use one of the audio tools. Okay, so see, it has generation, right? Generate image and whatnot. So it's gonna use some model as well, list voices. See, it is running internally. We are able to see that. Similarly, generate an image of a person with a whiteboard. Okay, and it's written MeshAPI is the best on the board. Okay, so it would also generate an image then. See, it is doing all of those things. It will generate a thing, and I'm also telling it, generate an image. So it would also generate an image. See, outputs folder is made already. And similarly, we can also tell it to make a video and whatever tools you were able to see, web search. Okay, so web search using MeshAPI about the latest AI news. Okay, so it's also going to do that. All right, see, it is doing just its things. It has the access to everything. Now running it with MCP image tool. See, we have this audio. MeshAPI is amazing. You can hear that. So I'm gonna play this.
MeshAPI MCP is amazing.
Right, we were able to hear this, and it just picks something, right? It will also pick up Hindi models for you. Generate image, it is working on images as well, and in no time you will have the image generator as well, right? So your coding agents really don't do all of these things, but with the help of MeshAPI, okay, we were able to do all of these things. Okay, it will also be able to do web search and whatnot, and it can just give you the image. See, generate image is working right now, right? So I hope you like this. I hope now you know how would you use MeshAPI MCP, right? And that is all for this video. I'll see you in the next video where we'll use MeshAPI as a CLI instead of what do you say, instead of our Claude code agent, we'll use MeshAPI as CLI, right? And that would be fun. So this Claude code will be replaced, and you'll see how exactly it is replaced. Currently, it has also generated this particular image. MeshAPI is the best. I think this is what we asked it to generate, and we also see this in action. In this video, we are going to use MeshAPI instead of this Claude code. I'll tell you how. First, you have to open your command prompt. After you have opened your command prompt, you have to write this particular command. Let me close this. And I will also be adding some documents for you. Okay, so that you know what we are doing. See, I've added CL and Claude code, MCP capabilities, MeshAPI versus Claude code. So you can read all of that. All right. Next, let me add UV tool install MeshAPI code. So using this, we can have MeshAPI in our CLI. It is going to install that. Okay. It is going to install it. And we can check if if MeshAPI version command shows up. Okay. Let me clear the screen. Let me hit this command. So let us see if MeshAPI is recognized right now. Okay. It should work. MeshAPI is also recognized. All right. Now what we can do is we have to get it on path. Okay. And everything is given over here. Okay. CLI and Claude code, everything, all of this setup is given to you. Okay, see, UV tool install, set path and whatnot, it is given to you. Okay, what I would do is I would just copy this particular thing. Okay, set path, I would add it over here. Path is set. Okay, now what do we have to do? We have to write UV tool update shell. Okay, so I'm just gonna update my shell. All right, it is already in the path, right? Lastly, what do I have to do is I have to set, okay, I have to set MeshAPI key. Okay, so what I will do is, let me, squeeze this a bit. Okay, and let me set my Mesh API key and clear the screen quickly. And my Mesh API key is set. Okay, you have to set your Mesh API key. Once this is set, okay, once all of this process is done, we just simply have to do this step. Okay, we have to open our command prompt and we have to write Mesh API. And see, just like Claude Code, Mesh API is started. Okay, I can just simply take the terminal over here. So we have Mesh API. Hi, who are you? So it's going to tell us that it's Claude Sonnet. Claude Sonnet model is being used. Okay, it is giving us some response. And one thing, please note, when you use Claude Code via your subscription, okay, whatever subscription you has, less dollars are consumed. But when you use Claude Code via API, there is a very high shoot in usage of Claude Code Sonnet. See, in one request we utilize so many tokens. Okay, Claude Sonnet, right? From here now you can switch to models. Okay, models. Once you do this, let me show you models. So I think you have a command of switch models, maybe. All right, I think it is models. Once I click this, I should be able to see all the models, right? See, this is the list of all the models which I'm seeing over here. Let me close this. See, list of all the models, right? So there is a way, I think, to swap the model as well. I'm not able to, switch model or change model, something, some command we have. You can explore that. Okay, you can explore that part. So I can just, yeah, I think we had over there model switch. Nevertheless, okay, I can just press shift tab to change this from auto mode on, right? Just how all the things which we do in our Claude Code, we can do this in this terminal as well. Okay, currently I won't be doing it. Let me show you something, some CLI commands over here. I think we have mentioned a few commands over here. See, model name switch model. Okay, so we first have to give the model name. So we can do something like this, right? We have something like this. Okay, we can do something like this. Okay, if we want to launch it with OpenAI itself, so see, let me quit it. Okay, if I quit, how it is. Okay, quit, exit, sorry. Okay, we have exited. Let us say we directly want to start with OpenAI. So I can just use OpenAI GPT-4o. Now, if I show you the model, it is OpenAI, right? Routing, we can also do auto. So for different requests, it can use it. So please explore this. Okay, I've given you everything. I've also given you the commands. You can use \help. Okay, \help to get all of these different commands, how you can use what and whatnot. I would just really save my tokens over here because I have Claude Code for coding agent. I just wanted to show you that how you can use Mesh API as well for your coding agent. It will absolutely do all of your tasks. Okay, if you ask it to read any of the file, okay, let me ask it to read this research.md. Okay, write in one line. Okay, write in one line about research.md. Okay, so it's going to open it. We are asking it yes. Okay, we can change this default modes as well. See, auto mode on. The docs is a file comprehensive inventory of MeshAPI features against official documentation. So now you know that I was saying the truth. Okay, this is your coding agent and that's how you use it. So yes, that was all for this particular video. I hope you enjoyed it and I hope you loved it, right? All this material will be given to you. There is one last thing which I would like to show you. Okay, there is this one last thing. Okay, now let me show you this. This is the same notebook which we have been doing and I have given you a surprise. Okay, this is everything is the same. Okay, everything is the same. Okay, I will be giving you this via GitHub. Now there is one thing I have added for you, native RAG app. Okay, in which we have configuration, data, main.py. Okay, you are very smart enough. I know you can just read this code. It has data, it has main.python file. I can show you this. I'm giving you this as an assignment, decode this entire process. All right, this is an amazing workflow wherein I can just run this for you. Okay, if you open the native RAG app, okay, I think the terminal is now here, right? So let me take the terminal here back. Terminal is here. Let me close this. Okay, once I open the command prompt, we are in here. Okay, this is native RAG app which I have provided. You have all the commands to run it. All right, and we should have that UV command as well. This is the UV command. Okay, let me copy it correctly. Okay, oops, I'm just copying it. Okay, I've copied it. I'm just gonna take it here. I'm gonna open it to 8000 port and something is gonna open up. Okay, let me open up a web page or something. So I think it is here, and I can just simply open localhost 8000. Here a RAG app would open, and here here I can give my voice input. All right, see, voice input. So I can give this voice input and speak the answer back. So it's gonna allow. What happens if I go over my storage limit? I've given this, it is transcribing. Okay, and I would also
In your plans, limit pauses new uploads until you upgrade.
So I hope you were able to see the response story, where it has got all the references from. Okay, so you can try this simple RAG app. It is made completely using your Mesh API only. We have not used anything externally. Mesh API is built-in RAG, file upload, search, no Pinecone, no vector DB. We have also added speech to text and text to speech. Everything for you to explore. So make sure that you will explore. And yes, that was our assignment. And that was all about Mesh API. I hope you enjoyed it and I hope you loved all the features of Mesh API.